Good morning everyone and welcome to today's webinar. My name is Pratik. I'm an application engineer at Prolim and today's topic for the webinar is Solid Edge Design Configurator. The Design Configurator has been recently introduced inside the Solid Edge portfolio. So let's take a look at how exactly to use the Design Configurator. The Solid Edge Design Configurator delivers a powerful design automation capability which is beneficial for the industries because it eliminates the expensive manual design customization which are more error prone and time consuming. The UI for Solid Edge Design Configurator is quite easy and user friendly. It is an easy 5-step process where you first capture the models and collect the input fields. Then you define the global rules and the model actions, and the last step is where you play and configure. So now let's hop into Solid Edge and take a look at Design Configurator in action. So this is a conveyor assembly I have in front of me, and as you can see from the edge bar here, I have turned on the Design Configurator tab. So the first step, as we discussed, is where you decide the specific components that you want to include inside your design configuration. So there are a couple of ways to do that. The first step would be selecting it from this option here, and then you can check the boxes for the specific components that you want inside the configuration. And the other way is my preferred way, where you select the components from the pathfinder one by one, and then just hit add selected, which will automatically add all the components that are going to take part in the design configuration. Now let's move on to the next step, where we define all the input fields, which is going to be the step number 2. So the process here is very simple. You add your input name, which in this case my first input field is going to be max load, and the checkbox means this is a required field, so I'm going to just check that box, and the type is going to be decimal since it's a numerical value, and label is max load capacity of conveyor. So name is so the name that we have defined is something for our own sake, and the label is something that's going to be displayed at the end of step 5. Once we have defined the name, the field, and the label, let's move on to the render style. So let's set the render style to radius, and the two values that we are going to set here is 50 and 100. So we have a 50 kg load max, and then we have a 100 kg load. So this is how you define your input fields. So we have a couple of input fields which I'm going to be defining one by one. So the first one was the maximum load. The second one here is the aluminum. Second is going to be the frame style. So let's set this one as frame style, which is again a required field, and this time it is going to be a text format, and the label is going to be frame. Render style, we are going to set to drop down, and the value here is going to be aluminum and stainless steel. So there are a couple of ways in which you can add the values. You can double tap and add the value manually, or you can use the add multiple values option and just type in the values here. This add multiple values dialog box is really helpful when you're trying to add values from Excel file or say a Word file. You can directly copy paste the values and add them here. Now let's move on to the next next field, which is going to be the frame color. So let's say color here, which is again a required field, a text format, and the name that we're going to give is frame color. The render style we are going to set here to radius, and again the colors that we have here are going to be orange, blue, and green. So let's move to the step 5 and see how exactly the configuration process is going to look like. Here you have your maximum load capacity of the conveyor, from where you can select the load, the load capacity, which is 50 or 100 kg max. From the drop down you can select aluminum or stainless steel, and then you have 3 different colors here. So we'll just go back to step 2 and see one more functionality that we have here is adding the images, which is really helpful at the end of step 5 to easily interpret the particular input field. So there are a couple of ways to add this. So we'll go one step back, and inside the embedded file resources I'm just going to be adding all the input fields here. So these are all the images that I'm going to be using as my input field references. So once all these images are added in the embedded file resources, I can come back to step 2 and here just say add the image and select the color, that is orange here. Again come back and select blue, and if you come here and select green, you'll see that all these images have been added. And if you go to the last step, this is how it is going to look. Your maximum load capacity of the conveyor and everything else is the same, and now instead of your actual text format you have the colors. So you have orange, you have blue, and you have green. So yeah, so that was some of the input fields. So let's complete all the input fields that we are going to be needing. So we have one more input field, that is going to be the roller type, which is again a required input field and in the form of a text format, and let's give the name label as roller type. Set the render style to radius and add the value here. So we have two different roller types. We have our steel roller and then we have our rubber roller. We also have the images for these two, which is going to be the first one is the steel roller and the second one is a rubber roller here. So we'll just add the images here. So after the roller type, one more input field that we have here is the leg type. It is a required input field in the text format. Give the name leg type. Leg type, and set the render style to radius again. Here we have 3 different leg types. We have a round, we have a square leg type, and we have the aluminum leg type. So let's give it the names real quick. Square, and the last one is aluminum. And also we have the images for each one of them. So the leg type here is going to be round, then we have the square, and then we have the last one, that is aluminum. And after leg we have our foot type. So we have our foot, which is a text format again, which is one of the input fields again. Let's say feet. The render style is again set to radius, and we have 2 different feet. We have a round feet and we have a square feet. So let's give it the respective names, round and square. inside the images we also have the images for each one of them. So this is a round type, and this is the square type. So once we have added all the images and and the input fields, let's go ahead and take a look. So we have our two different load types. You have your aluminum and stainless steel. Frame type, you have your orange, blue and green colors. Leg type and feet type. So everything here seems good. So step 2 is where you define your input fields. So since we'll be changing the length and the width of the conveyor as well, so what we would like to do here is that we will just go ahead and take a look at the actual length that is set right now. So we will just go to inspect and check the actual length. So the current length is 80 and the pitch is going to be 40. So our lengths are going to be in the multiple of 40. So let's add the fields here. So we have our length, which is going to be in a decimal format. Since length is a numerical value, we are going to say conveyor length let's set the render style to drop down, and the three values which we are going to be using is 800, which is the actual length. Next we'll choose 1000, which is a multiple of 40, and we'll choose 1120, which is again a multiple of 40. And now let's take a look at the width here using the smart dimension. So the length is set to 720. So let's the width is has a value of 720. So let's set the width again. The render style is going to be drop down. The value here is 5. We are going to set 2 or 3 different values, which is 520. Then we have our 620, and then finally we have the 720 value. So let's go back and see if everything is fine. The conveyor length we have 800, 1000 and 1120. Looks good. And for conveyor width we have 520, 620 and 720. So everything looks good here. So this was step 2, where you define all the input fields which are going to be driving your actual design configuration at the end of step 5. Before we move on to the next step, let's discuss one of the functionalities that we have here, which is the visibility rules. So let's say, for example, I'm going to set a visibility rule for a specific material. So I do not want to use the aluminum material when my input load is more or equal to 100 kg. So let's define the input rules here. The input max load we do not want to use when the value is 100. We can simply validate. We get a green sign, which means the visibility rule is just working fine, and hit OK, so that the visibility rule is applied. So if we come to the last step here, now when I select my load to be 50 kgs, I have both the materials, that is the aluminum and stainless steel. But now if I decide my maximum load capacity is 100 kg, the frame style available is only stainless steel, because we have set the visibility rule for aluminum to be turned off when the load is equal to or greater than 100 kg. So this was something about the visibility rule, which is really helpful to segregate your output results. Now let's move on to the third step, where you define the global rules. So in this case, I'm going to be defining a mapping rule. Let's give it a name, say conveyor type. So in this case, I'm going to be defining different types of conveyors. For example, a light conveyor, a normal conveyor, and a heavy duty conveyor based upon the input loads and the material used for the frame. So let's start with that. First, let's define an input load of 50 kgs. Next, let's define an input load of 100 kg. And now let's define an input frame material, which is going to be the aluminum first. And then finally we have our stainless steel. So now that we have defined all the input parameters in one row, let's define the rules. So we have our 3 columns. So when our load is 50 kg and the material is aluminum, the conveyor type we are going to define is going to be a light conveyor. When the input load is 50 kg and the material used is stainless steel, the conveyor is going to be defined as normal conveyor. And when the input load is 100 kg and the stainless steel is a material, we are going to be defining this as our heavy duty conveyor. Now that we have defined the global rules, using the new global rules inside step 2, we can define the visibility of different input fields. So let's take a look at that as well. In this case, let's define the visibility rule for rubber here. So we do not want to use the rubber type of rollers when we have our heavy duty conveyors. Also, we are going to define some visibility rules for the leg type. In this case, for the round visibility rules, in this case for the round leg type, we are going to define the conveyor type as a normal conveyor. So let's say the conveyor type is defined as normal here. Validate, everything looks good, so we'll move on to the next one. For square, we want to use the square type of legs for everything but apart from the light conveyors. So we can define that here as well. Everything but light conveyors. And then finally we have our aluminum leg type, which we will only be using for the light conveyor. So let's say conveyor type is equal to light. Everything looks good here. So yeah, so this is how you can use the global rules to define your visibility. And now let's move on and check if the UI is actually working. So let's say for our 50 kg load and the material aluminum, If you scroll down and see, the only leg type you'll see is aluminum here, since we have defined the aluminum as a light type of conveyor. And for a 50 kg max load and material stainless steel, you have your square as well as the round type of legs, and for 100 kg max you only have your square legs. So the UI tests out fine and everything looks good. So this is how you can use the global rules to define the visibility at the end of step 5 here, which is really helpful to segregate your outputs. So now let's move on to the next step, which is step 4, where you define your model actions. So here you'll see two different tabs. The first one shows you all the components that take part in your design configuration. With this you have the ability to change the order of the components based upon the priorities. So just for the sake of convenience, I'm going to set my part here, and then the next step is where I can define the replace model action. So select the component and then come to replace the model. So here we have two different columns, where the first one is going to be the place where you add the reference model. So I'm just going to browse to the file and select my reference model, and then I define expression when this reference model will be used. So in this case, the reference model will be used when the input frame is set to stainless steel. Everything looks good. Hit OK, and your first replace model action is ready. Similarly, since we have two different materials, we'll need two different replace model actions. So next replace model action, again browse to the documents and select the next option, and this time it is going to be the aluminum. So this component is basically the aluminum frame, where I'm going to select the input frame and define the conditions for aluminum as the frame material. So this is how you define the replace model actions. We have a couple of more, like defining the input length. So for the input length, we are going to set a variable and select the contour and select the particular length. So in this case, we have 800 millimeters as our length for reference, and this length will be changing based upon the input parameters. So in this case, we have our length, input length as an input parameter, so it checks out fine. And the last one here is where we define the input color for the frame using the set face style. So you have a couple of options. Either you can do it with the help of expression, or select the color from the drop down from the default solid edge library. So in this case, I'm going to be selecting by expression, and the expression that we are going to enter is use the input color here, validate and check. Now that we have defined all the model actions for one side of the frame, we can follow the similar process for the other side of the frame as well, and so on and so forth for all other parts which are involved in this specific design configuration. But there is another way apart from doing this process. There is a second method which you can use, which is done with the help of expressions. So let's take a look at that. So now we'll be replacing the leg type using the expressions. In order to achieve this, we'll have to come back a step in step number 3 and define the model path here. So let's start by creating a model path. give it a name as model path, and set the variable type to text and give it an expression. So in order to achieve and direct the changes to the specific assembly, you can come to functions, and from path here you'll see that you have the path to dr full path. So this is going to be guiding to your assembly, and then you'll have to set your assembly path, the location of the assembly where it is located, validate to see if it's working right, and there you go. So this is how you can define the model path for the entire assembly. Similarly, we have other components that need a replacement as well, like leg. So let's start by creating a new simple expression for leg. So change its name to leg file name. Change the variable type to text, and then again define the expression. So in this case, the way that you can define the expression here is that you'll have to come to the browse option here where you have located all the files. So in this case, you'll see that you'll have to find the specific file that is your leg. In this case, I have the file name BUP00495 is my file name, and the letter A, R, and S are going to be the types of legs, which is going to be the aluminum, round, and square. So in this case, we'll just copy the part that is similar until 5 and copy paste it. After that, we'll point out the input leg type here, and then state what kind of file do we have. So since this is a part file, we are going to say it's a .par. Validate to check if everything is right, looks good, and then we are going to save it here like this. So as such, you can define the leg type. Similarly, we are going to do the foot type as well. So we'll just do simple expressions, foot file name, change the variable type to text, define expressions, and we'll just copy paste the same thing, but in this case it's going to be for the foot type. So we'll just browse down and check. It is 439 with the ending, and in this case you'll see that for the ending 439 is going to be the round leg type, but in this case it's an assembly file. So that doesn't change a lot of things. So we'll just copy the part that is similar here. Point to the input foot here and define what kind of file do we have. In this case, we have an assembly file, so we say .asm. Validate and check if everything is right, looks good, and then move on. And lastly, we have the rollers. So we'll just go and create the expression, give it a name, say roller file name, change the variable type to text, and define the expressions in the same fashion. In this case, my rollers have the name as a BUP dash. So these are basically the rollers that I have. So let's copy paste the part that is common here, that is BUP dash. And since these rollers change along the way we change the input width, so we are going to add that as well, the input width. and finally the roller type. Once we check this, everything is working fine and looks good. So this is how you can define the expressions, and now we'll move on to step 4 and see how to define those model actions with the help of expressions that we just created. So now that we're in step 4, we will use the define model actions to replace the leg type. So the process here is same. Come to the add modules and hit replace model, but this time instead of replacing it with an actual model, we'll be using expressions that we just created, and we'll just say model path since it's pointing to the assembly, and the leg file name. Validate to check if everything is right. Looks good. And this is how you can do it for the other foot type as well. So in case of foot type, you'll have to come back, add the replace model, or select by model expression, and then finally define the model path and the foot file name. Validate to check if everything is right. Looks good, and then we move on. Now let's move to the last step where we will be configuring the model. So let's say 50 kg is the maximum load with a frame style aluminum. Let's set the roller type to rubber, then the leg type to aluminum frame, leg type again, the feet type to roller, and conveyor length 800 and conveyor width say 520, and let's hit create. So you'll see that within no time the configuration starts, and you have your configuration completed here. Now you can either just do a pack and go and save the assembly, or you can just restart the configuration. And now let's say the maximum conveyor load is 100 kg and the material type is stainless steel with a frame color. Let's take orange. Roller type is steel, leg type is square, and the feet type is square. Let's change the conveyor length to 1120 and the conveyor width to 620, and let's hit create now. Doing this, you'll see that the design configurator automatically changes all the parts based upon the color code and the expressions that we have set in step number 4, where we define the model actions. So this is how you can utilize the design configurator to its full potential. This is a very nice tool that the companies can utilize in order to achieve the specific configuration, and helps to save a lot of time, a lot of manual process, which is more error prone and time consuming. So definitely here is going to help us to save a lot of time. So thank you for attending today's webinar, and I am open to any questions that you might have now.